Mastering machine learning deployment. Bad models survive unless you track the right metrics. When evaluating the efficacy of our machine learning models in a production environment, what key performance indicators, KPIs, should we prioritize, and how will we quantitatively measure their success to ensure continuous improvement and operational excellence? The journey to operational excellence in machine learning deployment, it's a path fraught with twists and turns, where the rubber meets the road, and the theoretical meets the practical. I recall leading a project where we had to deploy a state-of-the-art recommender system for a major e-commerce player. The model was a marvel, but we soon realized that its performance in the lab wasn't translating to the real world. As I delved deeper into the issue, I realized that our team was struggling to make sense of the data. We had an abundance of metrics, but which ones mattered most? What were we optimizing for? It was as if we were trying to navigate a dense forest without a compass. I knew we needed to get clear on our objectives and set our sights on the right KPIs. First, we had to get past the noise. We started by identifying the outcomes that truly mattered to our stakeholders, in this case, the business leaders and end users. What were their pain points? What would make their lives easier? We distilled this down to a handful of key objectives, such as improving engagement, reducing churn, and increasing revenue. Suddenly, our focus shifted from tweaking model parameters to driving real-world impact. Next, we had to define success quantitatively. I worked closely with the data engineering team to instrument our system, creating a dashboard that tracked these vital signs in real time. We monitored metrics like precision, recall, and F1 score, but also kept a close eye on more nuanced indicators, such as model explainability and data freshness. This gave us a 360-degree view of our model's performance and helped us pinpoint areas for improvement. But here's the catch: these KPIs weren't set in stone. As we iterated on our model, we discovered that certain metrics became less important, while others took center stage. It was an iterative dance, where we refined our objectives based on new insights and emerging patterns. This adaptability was crucial, as it allowed us to stay focused on the ultimate goal, delivering value to our users. Throughout this process, I was acutely aware of the interplay between our team's collective expertise and the machine learning system itself. We had to balance the need for automation with the importance of human judgment. It was a delicate negotiation, where we had to convince the model to yield to our expertise, while also respecting its autonomy. In the end, this tension gave rise to a powerful symbiosis, where the strengths of both humans and machines combined to create something truly remarkable. As I look back on this experience, I'm reminded of the importance of staying grounded in reality. It's easy to get lost in the weeds of model optimization, but ultimately, our success hinged on understanding the needs of our stakeholders and aligning our efforts with their goals. By doing so, we created a system that was greater than the sum of its parts, one that continued to learn, adapt, and improve over time. In the pursuit of operational excellence, I've come to realize that it's not just about tweaking metrics or fine-tuning models. It's about cultivating a deep understanding of the ecosystem in which we operate, the people, the data, the business goals, and the technology. It's about fostering an environment where humans and machines collaborate seamlessly, where data informs decisions, and where continuous learning is the norm. When we get this right, the KPIs will take care of themselves, and our machine learning systems will truly come alive. To ensure operational excellence in machine learning deployment, it is crucial to prioritize and track key performance indicators, KPIs, that quantify the model's efficacy in a production environment. These KPIs serve as metrics to evaluate the model's performance, identify areas for improvement, and optimize its operation. The following KPIs should be prioritized, along with a description of how to quantitatively measure their success. 1. Model accuracy. This KPI measures the model's ability to make accurate predictions or classifications. Quantitative measure. Calculate the model's accuracy using metrics such as precision, recall, F1 score, mean squared error, MSE, or mean absolute error, MAE, depending on the problem type. Target threshold, achieve an accuracy of at least 95% for critical applications, with a tolerance of plus or minus 5% for non-critical applications. 2. Model latency. This KPI measures the time it takes for the model to process and return predictions or classifications. Quantitative measure. Measure the average latency in milliseconds, ms, or seconds, using tools like Prometheus, Grafana, or New Relic. Target threshold. Maintain an average latency of less than or equal to 500 milliseconds for real-time applications, less than or equal to 1 second for near real-time applications, and less than or equal to 5 seconds for batch processing applications. 3. Model throughput. This KPI measures the number of predictions or classifications the model can process within a given time frame. Quantitative measure. Calculate the throughput in terms of requests per second, RPS, or transactions per second, TPS, using tools like Apache Bench, Gatling, or JMeter. Target threshold. Achieve a minimum throughput of 100 RPS for low-volume applications, 500 RPS for medium-volume applications, and 1000 RPS for high-volume applications. 4. Data quality. This KPI measures the quality and integrity of the data used to train and deploy the model. Quantitative measure. Calculate data quality metrics such as data completeness, data accuracy, and data consistency using data profiling tools like Pandas Profiling or Data Validator. Target threshold. Maintain a data quality score of at least 90% with a tolerance of plus or minus 5%. 5. Model explainability. This KPI measures the ability to understand and interpret the model's predictions or classifications. Quantitative measure. Calculate explainability metrics such as feature importance, partial dependence plots, or SHAP values using techniques like LIME, Tree Explainer, or SHAP. Target threshold. Achieve an explainability score of at least 80% with a tolerance of plus or minus 10%. 6. Model fairness. This KPI measures the model's bias and fairness in terms of demographic or sensitive attributes. Quantitative measure. Calculate fairness metrics such as demographic parity, equalized odds, or statistical parity using tools like FairLearn or IBM Fairness 360. Target threshold. Achieve a fairness score of at least 90% with a tolerance of plus or minus 5%. 7. Model robustness. This KPI measures the model's ability to withstand data drift, outliers, or adversarial attacks. Quantitative measure. Calculate robustness metrics such as data drift detection, outlier detection, or adversarial attack detection using techniques like machine learning-based anomaly detection or ensemble methods. Target threshold. Achieve a robustness score of at least 85% with a tolerance of plus or minus 10%. 8. System availability. This KPI measures the model's availability and uptime in the production environment. Quantitative measure. Calculate system availability using metrics such as uptime percentage, mean time to recover, MTTR, or mean time between failures, MTBF, using tools like Prometheus, Grafana, or Nagios. Target threshold. Maintain a system availability of at least 95% with a tolerance of plus or minus 0.5%. 9. Resource utilization. This KPI measures the model's resource consumption, including CPU, memory, and storage. Quantitative measure. Calculate resource utilization metrics such as CPU usage, memory usage, or storage usage using tools like Prometheus, Grafana, or resource monitoring agents. Target threshold. Maintain resource utilization within 70% of available resources with a tolerance of plus or minus 10%. 10. Cost efficiency. This KPI measures the model's cost effectiveness in terms of infrastructure, maintenance, and support. Quantitative measure. Calculate cost efficiency metrics such as cost per prediction, Cost per transaction, or total cost of ownership, TCO, using financial analysis tools or cost estimation models. Target threshold, achieve a cost efficiency score of at least 80%, with a tolerance of plus or minus 15%. To ensure continuous improvement and operational excellence, it is essential to regularly monitor and track these KPIs using automated reporting and visualization tools. Establish a feedback loop to collect insights from stakeholders, domain experts, and end users. Perform root cause analysis for KPI deviations and implement corrective actions. Conduct regular model retraining, hyperparameter tuning, and deployment to adapt to changing data distributions or business requirements. Implement continuous integration, continuous deployment, CI/CD, and continuous monitoring to ensure efficient and reliable model deployment. Foster a culture of experimentation, innovation, and knowledge sharing within the organization. Provide ongoing training and support to ensure that machine learning engineers, data scientists, and other stakeholders have the necessary skills to maintain and improve the model. By prioritizing and measuring these KPIs, organizations can ensure operational excellence in machine learning deployment, drive business value, and stay competitive in the market.